All right, so I'm going to attempt, this will be my second attempt. My last attempt was too long. So quiz 3, problem 3, example. We're going to take the limit as x approaches infinity of the function square root of x squared plus 5x plus 5 minus x. Now, since this is a continuous function and x is a continuous function, you can use the substitution method to put infinity in. And what we get is infinity minus infinity. This is an indeterminate form. In order to use L'Hopital's, we need it in the form f of x over g of x. To do that, we're going to multiply the square root of x squared plus 5x plus 5 minus x by its conjugate, which means everything's the same except for we change this sign here in the middle. And we're going to multiply the numerator and denominator by that so that we aren't changing the problem. So that means we now have the square root of x squared plus 5x plus 5 minus x times the square root of x squared plus 5x plus 5 plus x all over the square root of x squared plus 5x plus 5 plus x. Okay? And when we FOIL this out, the middle terms are going to cancel because we have a negative x times the square root of x squared plus 5x plus 5 and a positive square root of x squared plus 5x plus 5 times x. So those two terms will cancel, and we'll be left with the square root of x squared plus 5x plus 5 times itself, which means we no longer have square roots. And then we have minus x times x, which is x squared. That's our new numerator, and it's still over x squared plus 5x plus 5 plus x. So now these x squareds cancel. And if we're going to take the limit as x approaches infinity, we have now infinity plus 5 divided by infinity plus infinity, which means this is equal to infinity over infinity, and it is in the indeterminate form in which we can apply L'Hopital's. And that suggests that this limit is equal to, due to L'Hopital's, the derivative of the numerator, 5, divided by the derivative of the denominator, which is 1/2 times 1 over the square root of x squared plus 5x plus 5 times the derivative of what's inside, which is 2x plus 5 plus 1. Okay? So let me squeeze. We're going to take the limit as x approaches infinity here. We're going to squeeze that in. Sorry. So when we take this limit as x goes to infinity, 5 is still going to be 5, and 1 is still going to be 1. The only thing that we need to figure out now is what happens to this term right here. So what we're going to do is we're going to come down here and say, well, what is this limit as x approaches infinity of, this is in the numerator, so 2x plus 5 divided by 2 times the square root of x squared plus 5x plus 5. Okay? So, so now the thing is that we can split this up into two pieces, which is the limit as x approaches infinity of 2x over 2 times the square root of x squared plus 5x plus 5 plus 5, a constant, over 2 times the square root of x squared plus 5x plus 5. Now, if you let x go to infinity, then this term right here is going to infinity, and we're taking 5 divided by infinity, which means that this term right here goes to 0. And now we look at this term. Now, instead of applying L'Hopital's rule, we're going to use this trick where, since we're dealing with only positive x's, we can say x is equal to the square root of x squared, which normally is equal to the absolute value of x. But the absolute value of all positive x's is just x. So we're going to do that, and that way we can put everything inside one square root. So we have the limit as x approaches infinity of the square root of x squared divided by x squared plus 5x plus 5. Okay? Now, what we learned from linearity as the limit of the square root of this stuff is equal to the square root of the limit as x approaches infinity of x squared over x squared plus 5x plus 5. Now, you can use L'Hopital's here, or what we can do is we can take the leading term in the numerator and the leading term in the denominator and say this limit is equal to the limit as x approaches infinity of the leading term x squared divided by the leading term in the numerator x squared divided by the leading term in the denominator x squared. The leading term being the term with the largest power, the term that's going to be the biggest as x goes to infinity. So here, this is just 1, right? So this equals the square root of 1. Well, the square root of 1 is just equal to 1. And that means we can take this now and put it back up there into this one that we branched off of before. So now, as x goes off into infinity, 5 stays at 5. This term right here, 1/2 times 1 over x squared plus 5x plus 5 times 2x plus 5, that approaches 1. And 1 remains 1. So what we're left with now is 5 over 2, 5/2. And that is exactly what I got on Wolfram Alpha when I typed it in and had them do it. So my algebra matches their algebra, and there you go. Couple tricks. We used a conjugate. We used linearity, branched off, used our little square root of the square trick, came up with a limit, plugged it back in, got 5/2. And that's all for this problem.